Hi guys, like I promised yesterday, today we're going to do some examples of limits. Okay, we're going to start with this one. It says the limit when x approaches 3 of x squared minus x minus 6 over x minus 3. Okay, first thing is, this function has a domain, right? And the domain for this function is that x cannot be equal to 3. Okay, so the domain of this one is x cannot equal 3. And why is that? Because it gives you 0 in the denominator. Okay. Now, if you remember in all of the previous videos that I said that it doesn't matter if the value is not in the domain, you can still find the limit. Okay. And that's the biggest thing for limits, is to be able to do that, to find what value is it approaching to without actually inputting inside the function. Okay, because in this case it's not defined, but the limit is going to exist and you're going to see what is equal to. Now, if you plug in 3 in this equation, I'm going to have 3 squared, which is 9, minus 3, which is 6, minus 6, which is 0. So you're going to have 0 in the numerator and you're going to have 0 in the denominator. So this is called indeterminate form. So I'm going to write that down because it's important. And I'm going to talk about that later in more when we talk about L'Hopital's rule. But I'm just going to state that right now. So indeterminate form. I'm going to write that indeterminate. No, that's not how you write it. Indeterminate. Indeterminate form in this case is 0 over 0. Okay? There's other indeterminate forms, but we're just going to concentrate on the one that we're using right now, which is 0 over 0. Now, whenever you have 0 over 0, that means that you need to cancel a factor to eliminate that 0. Okay? So in this case, what we want to cancel is x minus 3. So what's x squared minus x minus 6 factor into? Well, this is the limit when x approaches 3 of what? What two factors of negative 6 when you multiply them together gives you negative 6. When you add them together gives you negative 1. Okay, so it sounds like it's negative 3, positive 2, right? So x minus 3 and x plus 2. And voila. Now we have this. Notice that you can cancel these two factors and you get the limit when x approaches 3 of x plus 2. And now you can evaluate 3 and get 3 plus 2, which is 5. Okay? Notice that I've jumped all the theorems, but I used them all. I used the division theorem, I used the multiplication theorem, and I used the addition theorem. But now that we have those theorems, we don't have to state them over and over and over again when we're doing these problems. We can just use them automatically. So that's the value of the limit. Now, one thing that I was confused about when I was younger was, wait a minute, isn't this function already equal to x plus 2? So, right? Because if you take away the limit, it's still going to cancel and it's still going to give you x plus 2. But then later on, once I had more experience, I learned that it is a different function because the domain is restricted for this particular function. X cannot be equal to 3. Now the function x plus 2 has no restriction in the domain. So if I were to draw this function, it will be the same line of x plus 2, but with the hole, an open circle, in the value for x equals to 3. That's the main difference. It sounds like it's not a big deal, but it is, okay? Because there are two different functions. Just because that little hole in there, okay? Now the next problem is very similar to this one. So hopefully you already know what I'm gonna do. If I plug in 4, first of all, x cannot be equal to 4 in the domain. So x is not equal to 4 in the domain. Now if I plug in 4, I'm going to get 0 over 0, right? 16 minus 12 minus 4 is 0. Squared 0. Now the only difference between the first one and the second one, the first problem and the second problem, is that this one has a square, but it's basically the same thing, okay? So again, we factorize. So this is the limit. X approaches 4. What is the factorization here? What two factors of -4, when you add them together, gives you -3? Well, it sounds to me that's -4 and +1. So you have x minus 4 and x plus 1 divided by x minus 4. Okay? And now these two cancel, and I have the limit. Let me push. Okay? When x approaches 4 of x plus 1. And again, we have the value 5. Okay? So notice again, oh wait, I forgot the squares. My bad, my bad. Square, square here. Oh man, terrible, terrible. So square, square. Okay, so now it only cancels 1. So you have limit when x approaches 4 of x minus 4 times x plus 1 squared. Okay? Now we plug in. If we plug in 4, we get what? 4 minus 4 is 0. 4 plus 1 is 5. Squared is 25. So 0 times 25 is just 0. Okay? So the limit is 0. Again, this one, I'm not going to go into too deep how it's going to look like. You can graph it in your graphing calculator and see that it's basically a parabola with a hole in 4. Okay? Now, let's look at this one. This one's a little tricky. It's not that obvious. So if you plug in 2, you get again 0 over 0. X cannot be equal to 2 in the domain. So what do? Well, 1 over x minus 1/2. How do you subtract these two? Just like you will subtract any fraction, you find the common denominator, which is 2 and x. So this becomes what? Well, this is the limit. When x approaches 2, we multiply by 2 over 2. So this is 2 over 2x. We multiply by x over x. This is x over 2x. Notice that I forgot to mention that x is not equal to 0 in the domain also. Okay? So notice x cannot be equal to 0 because it's 1 over x. And x cannot be equal to 2 because it's going to give you 0 in the denominator. Now we continue here, x minus 2. This is equal to the limit when x approaches 2. Now that we have a common denominator, we can subtract these two. So you get 2 minus x over 2x over x minus 2. Okay? Now we keep going. Now, remember, the main goal, whenever you have 0 over 0, is to cancel a factor. We haven't canceled anything yet, so we have to keep going until we finally cancel something. Now, you have a fraction over a number, so you multiply by the reciprocal of the number in the denominator. So you have 2 minus x over 2x times 1 over x minus 2. Okay? And we continue. Now, it seems like 2 minus x and x minus 2 want to cancel, but it's not necessarily the same thing. 2 minus x is not equal to x minus 2. So you can't just cancel them because they look the same. Okay? We have to do one more step to be able to cancel, and that is to factor a negative number. Okay? So limit x approaches 2. If I factor -1, I have x minus 2 over 2x times 1 over x minus 2. Okay? Notice that using distribution, negative 1 times x is negative x, negative 1 times negative 2 is positive 2, which is the same thing as 2 minus x. So now that we have the same thing, we can cancel them. And we have negative 1 over 2x. And then we can plug in 2. So you got negative 1 over 2 times 2, which is 4. And that's your limit. Okay? Now let's go to the other one. Now this one is a little different. Notice that I've been trying to give you different examples on how to use the limit. It's gonna be fun once we start doing trigonometric limits, but for now these ones are very interesting also. So how will you do this one? Again, 0 over 0. If you plug in 9, you get 9 minus 9 is 0. If you plug in 9 in the denominator, you get square root of 9, which is 3. 3 minus 3 is 0. Okay. Again, the domain of this function is what? X greater or equal than 0, x not equal to 9. Okay? Remember, whenever there's a square root of x or square root, you have to restrict the domain for everything positive, because the square roots cannot be negative inside the square root. So that's the domain. What I'm writing on top is the domain, but I want you to get used to doing that because it's going to help a lot in calculus. Most of the things that people have trouble in calculus is finding the domain. It's a huge deal, and that's why I'm always doing it in all these problems. So I suggest you do the same. So now let's manipulate this to be able to cancel something, because we need to cancel something. So what can we do? Well, if you remember in pre-calc, we multiply by the conjugate of the denominator. So we have x minus 9 square root of x minus 3, and then square root of x plus 3, square root of x plus 3. Okay? Now, what I tell my students or my clients, whichever one, is that the numerator, don't expand it. Because what you're going to do is just plug in. So it's better to leave it alone. The denominator, you will expand it, but because it's the conjugate, it's just a difference of squares, right? So square root of x times square root of x is just x for the domain x greater or equal than 0. I'm not going to talk about that. And then, so if you know the property, okay, I'm just going to write it down. It's easier. A minus b times a plus b is what? A squared minus b squared. Okay? So this is the difference of squares. This is what we're going to use in the denominator. So square root of x is a. So square root of x squared. I'm going to write it down like that. Minus 3 is b. So 3 squared. Okay? And again, the numerator, leave it alone. Don't expand it. So now you just find those values, and notice that in every example I'm going to give about limits, don't forget the limit. Don't forget it. Your teacher's going to get annoyed, or your professor, and he's going to take points away. Because once you stop writing the limit, then you're doing something else. You're not finding the limit anymore. Okay? And it's not cool to just write in like before, like below. Oh, I forgot the limit, I'm just gonna write it here. No, write it in every step until you find the limit. Once you find the limit, then it's no need to write it again. Okay? My suggestion from the bottom of my heart, write always the limit. So again, so we got x minus 9 times square root of x plus 3 over x minus 9. Okay? Notice that now we can cancel these guys, and we have the limit when x approaches 9 of square root of x plus 3. Which is what? Well, we plug in 9, we have square root of 9, which is 3. 3 plus 3 is 6. Okay? And that's the limit. So notice, after I find the limit, I don't have to write limit again. It's redundant. Now our last example, you always need a piecewise function to make calculus harder. Find the limit when x approaches 3 of f of x if f of x is this piecewise function. So this one relates to the problem of before. The examples from one-sided limits. If you haven't seen that video, I suggest you see it first. I'm doing videos sequentially, so they all are in order. So don't skip them, okay? Okay, so we will find the limit from the left and the limit from the right, and if they're equal, then that's the value of the limit. So the limit when x approaches 3 from the left of f of x is equal to what? Well, x being approaching from the left of 3 will be x squared. So that's the value for that. That's the function that we're going to use from the left of 3. And this is just what? 9. Now the same thing for the right of 3. For the right of 3 is everything that's greater than 3, so it's the 2x plus 3. Now if you plug in 3, you get 2 times 3 is 6, plus 3 is 9. So the limit when x approaches 3 of f of x is equal to 9. Notice that this 7 here is a distractor. It doesn't affect the limit because we don't care what the value is at 3. We're just looking for the limits. Okay? And that's all for today. If you like the video, subscribe to Motivao, go to my website, and if you have any comments, you can comment below. Thank you again for everything. You guys are awesome. Bye.